a little bit introductory content that what are they, right? Now let's discuss something about all that the discussion that we had till now will be again repeated. So for long span structures, engineers commonly use cable or arch construction due to their efficiency. Right, I was discussing what is a problem with long span. Bending moment is going to be increased in square of length, okay, L square. So that's why the normal beam column constructions are not at all sufficient. They can't take care of the load, the span because of the long span. That's why we go for either cable or arch construction. Okay, so that is a point to be made. Structure may be classified into rigid and deformable structure depending on change in geometry of the structure while supporting the load. It's very common concern. So if you apply the load, if the geometry is unchanged, we say it is rigid structure. If you apply the load, if the geometry changes, we say deformable structure. Okay. So you have already studied extensively engineering mechanics, which is nothing but rigid body analysis of rigid bodies, and you have studied strength of materials and then structural analysis. All that it's completely deformable structures, analysis of deformable structures. Then rigid structures support externally applied loads without appreciable change in their shape. That was I was telling the same. So if you don't find any change in the geometry, we call it as rigid structure. So beams, trusses, and frames are examples of rigid structures. Okay, right. Unlike rigid structures, deformable structures undergo changes in their shape according to externally applied loads. Okay, so that's something that you will appreciate when I show you in terms of diagram. So it should be noted that deformations are still small. So cables and fabric structures are deformable structures. Okay. The cables are mainly used to support suspension roofs, bridges, and cable car system. Suspension roofs are very common in case of stadiums. Okay, so where this something like this, you will find an arena. So you have to provide the roof. No, this will be maybe the playing area. So this may be the seating arrangement. So you shall provide the shelter. I mean the protection for the people who are sitting in this. Okay, something like this. So what do? You have a structure where the roof shall be made like this. And then okay, so a cable. This is what. This is a roof. This is a roof suspended by cable. This is a cable. This cable. Okay, and this will be the roof. So this is supporting structure. Like maybe you can call it as a column or tower. So if you have supporting towers, okay. So likewise, all around the stadium, you will have such type of structures. This is what suspension roofs, right? Bridges just now you have seen. Cable car system. So when you travel to some places, historic places or no, scenic places, you will have cable car system, a valley, something like a valley. Best example, if you go to a valley, so you will be traveling by cable car system. So something like have a hillock, another hillock is connected by a cable. So you will have a cable car where you are sitting in a cable car and enjoying the beauty of the nature, right? So this is how the cable car system. So in all these cases, you see the purpose of cable. You see, purpose of cable here is to suspend the roof. Purpose of cable in bridges. Purpose of cable in cable car system. So this is what is important, right? Okay, right. Electrical transmission lines, antennas, radio antennas. Now you can talk about mobile towers, mobile signaling towers are also supported by cable. So you will find, okay, the cables in case of, okay, something like this. So radio antennas are supported by cables, and similarly electrical transmission lines are very common. So in all these cases, you have application of that. So cables are usually made of multiple strands of cold drawn high strength steel wires. Okay, so let me just clear for you to have a clear picture of that, what is written there. Okay, right. So what are cables made of? They have multiple strands of cold drawn high strength steel wires. I can say that HTS wires, high tensile steel, HTS wires, where the yield strength is around 1500, not just 550 grade steel or something like 1500 to 3000, roughly 3000 megapascal yield strength. Okay, so they're twisted together like the high strength steel wires twisted together will form a strand. So such strands are again twisted. There are multiple strands. Okay, so a group of 4 or 5 wires. Okay, 4 or 5 wires will be called as a strand. Such strands, like say 1, 2, 3, 4, something like that. Another strand, another strand. Okay, so each consisting of some 3 or 4 cables, like HTS wires. So this is called as cable. Okay, some 3 strands or 4 strands twisted together will form a cable. Okay, cable is not just a single wire as it sounds like. Cable consists of strands. Strand consists of HTS wires, right? So that is how it is. So practically inextensible under operating loading conditions. Okay, so they have as just I have told you, 4 to 5 times uh, strength. I mean sigma y value. Okay. So Fe 500 grade we talk about for normal HYSD steel. HYSD bar is having around 500 550 grade steel. So 4 times if you take 2000, 5 times 2500. Okay. So likewise. So this is how it is. So cables will carry only axial tension. Full potential of the cable cross section can be utilized in transferring forces. So this content is already known to you. So we'll be extensively explaining this in case of stresses in beams. How an axially loaded bar is different from laterally loaded member called beam. So therefore, cables are able to carry the same amount of force with a much smaller cross section compared to other structural system. Okay, so if you use beam, you are going to waste the material, whereas if you use cable, you are going to use full strength of the cable. So the same is written here. High strength to weight ratio makes cables very useful where lightweight systems are needed. Right? Whereas if you use beam or a very long span would require very large cross section, most of its potential will be used in carrying its own weight. This is the explained when I was discussing, showing a picture of the bridge. So if we use cables replacing the beam in combination with a beam instead, lighter structure will be required. So whose self weight will not add significantly to load effects. Okay, so this is how the importance of the cable is. The main disadvantage with the cables is due to flexible geometry. As the loading on the cable system changes, there can also be change in the cable geometry and subsequently on forces acting in the cable. This I'll explain you in a simple way. So imagine that there is a cable. So uh, put on two supports or tied to the two supports. So if I put a load here, the cable is going to have a shape like this. If I move the load to this position, the cable is going to take this shape. So the geometry is not fixed. It depends on the load, where the load is. That's a problem. That's a disadvantage. Okay. So unexpected forces may destabilize a cable system, causing excessive deformations. So if you design the cable for an expected force, it's okay. It will perform its duty. But if you have some unexpected forces coming, just like your beam column uh, construction, you don't have safety for this, no stability for this, right? So designers should be very careful on this regard while designing a cable system, along with other issues such as large forces at the anchors, large oscillations. So that you can see if you see this one. So go to Google, type Tacoma Narrows Bridge failure, and you will see what is the difficulty or disadvantage with the cable structures. Okay, so this is what explains you in detailed way what happened when you design a cable structure, right? So this is the cable stayed, a typical cable stayed bridge where unloaded cable, if you load it, the cable is going to take this shape. The shape is called funicular shape. Okay, right. So the shape assumed by a rope or a chain under the action of external load when hung from two supports is known as funicular shape. So cable is a funicular structure, means if you load it, it will change its shape and settle to a particular shape. So that's why always cable is a funicular structure. So it is easy to visualize that a cable hung from two supports subject to external load must be in tension. So now let us modify our definition of cable. Cable may be defined as the structure in pure tension having funicular shape of the load. Okay, so that's how cable is defined. Okay, right. So this is the introductory part. So we'll come back to the next lecture uh, with characteristics of cable and cable theorem, etc. Okay. So in this session, what we have talked is just the importance of cable structures, where the utility of the cable is meant for what it is meant for. Okay, and we have seen some examples where great bridges are being built, and how the cables are being used, and what makes you to opt for the cable, uh, the structure called cable. Okay, so why you choose cable to use. So all this information is being given in this session, right? Thank you.